Welcome, everyone, to the third tutorial of my passion project, Planarly. Planarly is an Affero GPL-licensed open-source research project to explore the potential of spreadsheets as a general-purpose two-dimensional programming environment. So far, we've looked at basic spreadsheet operations, worked with JSON, and interfaced with a charting library. This time, we'll look at reusing logic defined in sheets by turning them into functions. Suppose we're making a sheet that computes the square of a number, say 4. Just for illustration purposes, we compute it by generating a square region of size 4 by 4 filled with ones. And the result is the sum of this square region. And this sheet square works for different values of num. It feels almost like we've implemented a function in conventional programming, mapping some input values to some output values. What if we could actually invoke it like a function? For example, to compute the square of I, which is 3. Well, Planarly supports just that, reusing a sheet's logic as a function. Let's see how it's done. In the sheet square, we assign an additional label x0 to the num cell. Recall that any name starting with a capital letter is reserved in Planarly. Specifically, names starting with a capital X denote function parameters. x0 is the zeroth or leftmost parameter, and we assign a second label, return, with a capital R to the result cell. Now that the square sheet has its input parameter cell and output return cell defined, we can call it like a function, p.square3, which evaluates to 9. Recall that capital P means my parent node, therefore p.square is my sibling, square. This expression is asking, if we were to update p.square's x0 cell to 3, what would be the value of its return cell? And the answer is 9. These sheets as functions work just like functions in conventional programming languages. For example, Planarly's sheets as functions accept name parameters too. For example, if the sheet square were to support adding a number to its return value, we'd define a cell x add with a default value of 0. And the return cell is now sum hash ones plus x add. As expected, the cell to p.square 7 has not changed. But now, we can pass in a named parameter, add equals 1, and see that the return value has incremented by 1 from 49 to 50. The substitution of the parameter cells is completely hypothetical and does not affect the actual value in the square sheet. We call one set of such hypothetical substitutions an overlay. For example, the call p.square 7, add equals 1, creates an overlay comprising of two substitutions, square.x0 equals 7, and square.x add equals 1. Similarly, the expression p.square 3 plus p.square 4 would create two separate overlays, each containing a single substitution. The astute viewer would notice that we cannot place anything to the bottom or on the right of a table of indeterminate size. For example, if we set a value here, then square cannot be called with a value of 6 or above, because at 6, we get a spill conflict at this position. Planarly solves this problem using barriers. We can set this row as a barrier. Now when we try and spill across it, enough new rows are automatically created so that does not happen. These dark rows are called elastic rows, because they'll be removed as soon as the barriers are less stretched by the spills. Elastic cells cannot be labeled or assigned formulas, as they can disappear at any time. But other than that, they behave just like ordinary cells. For example, we have a region A to B that crosses the barrier. When the barrier is unstretched, the height of the region is only 2. Now that the elastic region is 2 rows tall, the height of A to B becomes 4. Although elastic cells can't have labels, we can reference them using, for example, movement operator down down. With the barrier in place, the result cell can be placed under the 1s region with undeterminate size without fear of a spill conflict. We have now seen simple sheets as functions, where the inputs and outputs are all single cells. In the next tutorial, we will look at passing tables as parameters to sheets as functions and returning tables as results. I hope you found the ideas in this demo interesting. Check out the website www.planarly.com, where you can try Planarly right in your browser. The software is being actively developed, so please be patient if you encounter any bugs or performance problems. The application runs entirely in the browser, and your data never leaves your computer. Please subscribe to my channel and follow me on Twitter, Dr. Planar. Stay tuned, and see you next time.